guys, it's good to see you all. I was thinking, since the Avengers broke up, and since times are so rough in the world these days, I thought maybe we should try to put a new group together. We could try to help students with their homework, and then we could fight evil in our spare time. I know, Thor, you could help with foreign languages because you speak Groot.
You speak Groot? Yes, the total on Asgard who was elected.
I am Groot.
But what do you guys think we should call this new group?
The Avengers.
Revenges?
Because I'm getting revenge. You're getting revenge. And you what do you want revenge?
I'm undecided.
I don't know about that name. I think that's a great idea. I agree with Groot. I think the group should be called the Math Avengers.
Cool? Cool. So cool.
I appreciate you guys bringing me into the group. So, for Thor especially, I heard about all your problems with your sister breaking your hammer, and she really did sound like the worst. So, I have a gift. For you. What do you think of this weapon?
A king's weapon. Meant to be the greatest in Asgard. In theory, it could even summon the Bifrost. It have a name?
Math Breaker.
He needs the axe.
He needs the axe right now? Don't worry, I got you, Thor. Here you go, pal. He needs the hammer now? Here you go, Thor. It's not the hammer, it's the axe. Algebra 2, we're in 11.2. So I'm mostly just reading from this notes paper to begin with, a few ideas. So the point of chapter 11 where we are is that we're trying to factor polynomials of degree 3 and higher to solve equations. Meaning you have a power that's 3 or higher, that's the degree, is the highest power. So this has degree 3. This problem right now, it equals 0. You have no idea really how to solve an equation like that. If I gave you something like this with the second power problem, you could try to factor it, or you could do the quadratic equation, quadratic formula, if it came down to it. But if we go x cubed, you don't know how to do that yet, but you will in about 10 minutes. This problem has a degree of 4. I ran out of word space to write the equal 0 at the end of this. But if you tried to solve this right now, you would have no idea how to even do that. But in about 12 minutes, you probably will. So that's the goal of this chapter, and we're going to start to develop those skills today, is if an equation gets higher than x squared, what do we do about that? So we're tapping into our words from yesterday. The words from yesterday were factors and roots. Something like, well, I'll just read the next line. X minus 3 would be an example of a factor. The corresponding root that goes with that factor, 3, can be called a root. Not a square root, mind you, but the word in this chapter is a root. Roots and factors are linked. They usually just have opposite, or always just have opposite signs. So if x minus 3 is a factor, if that's a true sentence, it is a true sentence that 3 is a root. Likewise, if x plus 2 is a factor, negative 2 is a root. And we've had things like that before. There are days that we've factored where you got things like x plus 3 and x minus 2. And that would tell, well, I'll switch the sign so it's more like you think. X minus 3 and x plus 2 are factors. This would tell you that 3 is a solution or a root. This would tell you that negative 2 is a root. Factors and roots have always been linked and still are. It's also true in this chapter that if you find a remainder by long dividing, it's the same as the value you get if you plugged in a number. So for example, if I long divide x plus 3 into this, and I'm not going to, but if I long divided x plus 3 into this, I'd get a remainder, some number. If I took negative 3 and I plugged negative 3 into this problem, I'd get the same number. The remainder, when you would divide a factor, it's the same number as the result if you would plug in a number. So if I took something like this and I plugged in 10, I'd get some giant number if I plugged 10 into this. If I long divided x minus 10 into that, I'd get the same number for a remainder. So the remainders, yesterday in the homework, we found a lot of remainders. Yesterday in the homework, we plugged in a lot of numbers. It turns out those things are the same. If you plug in a number, it's the same as finding the remainder if you divide it. So that's in the next sentence. If you found a remainder dividing in something like x minus 7, you get that same number resulting from just plugging in a 7. Another fact that will help us in this chapter, it's not shocking. X squared problems usually have 2 answers. X cubed problems usually will have 3. That's the most they could have. Sometimes it's less, but usually it's 3. X to the 4th usually has 4. The maximum number of roots or answers we'll find in this chapter is going to be given by the degree of the polynomial. So something like this might have 5 answers because it went to the 5th power. To speed us up though, we are not going to long divide anything again in this chapter. There's a shortcut thing that we'll delve into today that's called synthetic division, and synthetic division is going to be a really big time saver in this chapter. If you can remember how to do it, it'll also save you some time down the line, calculus and other courses that you'll take. Synthetic division is a good tool. I don't think many of you enjoy long dividing, so it's going to replace that with a different scheme. So here we go, learning about synthetic dividing to speed us on our way. Instead of writing x minus 2 outside of a box, the division box, switch the sign and put a positive 2 inside a little box that looks like this. And then don't worry about the variables, just make sure that we're going in descending order, cubes, squares, x's, and numbers. Just bring those coefficients, a 4, a negative 3, a 1, and visibly that had a 1, and a 7. We're just going to write those numbers straight across. I'm going to draw a solution bar straight across, but I'm going to make a little square for this last corner lined up with the 7. And then here's how synthetic division works. We're going to take this number and just drop it an exact copy. Anything I make on this bottom line, I'm going to multiply by what's in the box. So 4 times 2 is 8. I'm going to advance a line and put the 8 right under the negative 3. This times this made an 8. I'm always going to add down. If I add down, that's 5. Anything from the bottom line times what's in the box. 5 times 2 is 10. Advance that under the 1. Always add down. That's an 11. Bottom row times what's in the box is 22. Add down is 29. And then here's how we can reinterpret this into being an answer. If this started with x cubed, this will always start 1 power less. So if this was x cubed, this is an x squared, plus for positive, that's an x, because we're going to stay in descending order, plus an 11, and that has a remainder of 29. That is so much quicker than long dividing. Even doing it that way where I did that in like slow motion, that was way quicker than long dividing. If I were doing that at normal TMR the Math Wizard pace, the synthetic divide, this will be a little slower because I'll keep talking. Drop, times 2, add, times 2, add, times 2, add. With x cubed, that's x squared plus 5x plus 11 with the remainder of 29. That is super light speed. That is a fast way to long divide. So this kind of a setup could answer you a multitude of questions. It could answer the question, is x minus 2 a factor, like we did yesterday? No, because we were hoping for zeros. This could answer you the question, is 2 a root? No, because we were hoping for zeros. It could answer the question, what would it be if you plugged in 2? If you plugged 2 into that problem, you would get out 29. The little p of 2 on the notes is like an abbreviation meaning what would happen if you plugged in 2. Like 2 to the third is 8, times 4 is 32, 2 to the second is 4, times 3 is 12, plus 1 times a 2 plus a 7, 32 minus 12 is 20, plus 2 plus 7, 29. But that is a quicker way to go. So we'll go ahead and go again. So if you were asked to do this, I would never do that again. I would take the x plus 3 and make sure you do a negative 3 in the little corner square. Whatever this sign is, we're going to go opposite signage. And then we just need to go in descending order of numbers. 2x cubed, 7x squared. You have to take notice that they skip the x though and do a 0. If they skip a variable, we need a 0 in our synthetic division line. And then negative 5 goes there. And I'll go one slow motion and then one normal speed. So again, slow motion is you drop the 2 all the way through. Anything here on the bottom line will multiply what's in the box. 2 times negative 3 is negative 6. Always add down. That's a 1. Bottom row times what's in the box is negative 3. Always add down. Bottom row times what's in the box is 9. Add down. That's just the system for that. If you didn't catch that in the slow motion, rewind it, check that out again for those two. But if I were going to go normal pacing on that, I'm going to go drop, multiply, add, multiply, add, multiply, add. It should take about that long. Bottom row times, multiply times this, and look to add down. Since this was x cubed, that's x squared, plus x stuff minus a number, remainder 4. That could answer you a multitude of questions. It could answer the question, hey, long divide that, and get you this answer. It could answer the question, is x plus 3 a factor? No, so you didn't get a 0. Could answer the question, is negative 3 a root? No, because you didn't get a 0. Could answer the question, what would happen if you plugged negative 3 into this problem? You get out 4. It answers all of those questions by synthetic dividing. So all of the things we did yesterday, a longer way, synthetic dividing today has replaced them all. So turning my page to the back, I give this big long thing. This P of 10 means plug in the 10. I don't really feel like doing 10 to the 5th minus 2 times 10 to the 4th minus 7 times 10 to the 3rd plus 10 to the 2nd plus 20. If you want to do that, you could. It wouldn't be wrong. But I'd rather you practice your synthetic division skills today to figure out what would happen if you plugged in 10, put a 10 in the box. Anytime you're only given a basic number, just put it in the box unchanged. If they give you an xy thing, that's where we switch the sign. If they give you a factor, if they give you an xy kind of thing, switch the sign when you go to the box. But if they just give you a number, just go to the box with it. So synthetic dividing, we drop that, times 10 is 10, add down is 8, times 10 is 80, add down is 73, times 10 is 730, add down is 731, times that is 7310, add down is still 7310, times 10 again just adds on another 0, adding it down is 73,120. That's all we were after there. They asked us what would happen if we plugged in 10. We get this. That's all we care about. Next little baby step toward trying to solve is just being able to identify if something is a root. So here's a problem that if I let that equal 0, it could have up to 3 answers because it's an x cubed problem. So the first question is, would 2 be a root? Would 2 be a solution to this question? So copy the 1, the 6, the negative 1, the negative 30. No zeros that time because they didn't skip any variables on their road. If they give you a number, you just put that number in the box to see if 2 is a root. Just put 2 in the box. So drop the 1, times 2, add down, times 2, add down, times 2. We get 0, so 2. Yes, that is a root because I got 0. Same problem from the notes. I asked if 5 is a root. So to see if 5 is a root, I'll put 5 in the box. Drop the 1, times 5, add down, times 5, add down. Times 5, I don't even feel like it, because 5, no, I'm not going to get 0 there. And once I'm in the 50s, times 5 again and add it down. That had no shot. So nope. Third one I tried there was a -3. So is -3 a root? I'll clear some of that out of there. Drop the 1, times -3, add down, times -3, add down, times -3, add down, and yep. Okay, so that could have had up to 3 answers. I just found 2 of them there by doing that. Next question, I give you this. I have one thing I miswrote in the notes. It shouldn't say on here, is x minus 1 a root? It should say, is x minus 1 a factor? The factors are the xy things. The roots are just plain old numbers. Well, with x cubed plus 4x squared plus x minus 6, I wrote those coefficients across there. If we're seeing if x minus 1 is a factor, put a positive 1 in the box, because when we have factors with x's, we switch that sign. So 1 in the box, we're going to drop the 1, times 1, add down, times 1, add down, times 1, add down, we get a 0. Is that a factor? Yes. If it asks you to go beyond that and factor completely and solve, here's where an interesting thing happens. Since this was x cubed, this is x squared, plus 5x, plus 6. We got a 0 remainder, so we just left synthetic division world. That 1 could be invisible. If I asked you to solve a problem like this, you've been able to do that since Algebra 1. We took the x cubed problem, and by getting one lucky head start, we now have an x squared problem which can factor to be x plus 2, x plus 3. If we were asked to factor completely, we'd have the x minus 1 hint that they gave us. We'd have an x plus 2 that we just created, and an x plus 3 that we just created. Factoring completely would have those 3 factors. Solving would have 3 answers. A 1 that we had in the box before, and then an x plus 2 factor gives me a -2 root. An x plus 3 factor gives me a -3 for a root. I have 3 roots because it had a third power, and that makes some sense. On the side here, I have a couple helpful notes. One, you can spot if it's a root by a shortcut, seeing if the coefficients all add up to 0. So if I go back to where I was, this plus this plus this plus this makes 0. 1 has to work in a situation like that. Second thing that's worth mentioning, if I got to this level and couldn't have factored, the quadratic formula is still alive and well. If this was x squared plus 5x plus 7, or something weird like that, that couldn't factor, you can use the quadratic formula, and in this chapter, you will use the quadratic formula. Tonight you might not, but in chapter 11 you will. Another thing to take note of is that imaginary numbers, i's, are alive and well here in chapter 11. The i's could still happen. If you have something that goes into rooting negatives, you can get i's in this chapter, you will get i's in this chapter. Tonight's homework, I don't think so, but in the chapter 11 there will be some things with i's. So here's what we set out upon on our mission that I said in a few minutes you'd be able to do this problem. What we're trying to do is on this, without any kind of a hint or head start, just factor that and solve. There should be probably 3 answers because it's an x cubed problem. For you to do this, you're going to have to just start off and guess a number. So I gave you a shortcut for 1. If we added these up and got 0, it means 1 would be an answer. It doesn't do that, so 1 is not an answer. So I might try something like 2, or -1, or 3, or something. On the paper of notes here, it looks like I picked a -1. 2 would have also worked. But I'll just do what I did on the paper for consistency's sake, but -1 is going to work. 2 is also going to work. But I'll go -1 there. Dropping this times -1, adding down, times -1, adding down, times -1, gets me 0. -1 is one of my possibly 3 solutions. Since this was x cubed, this is x squared plus an x minus a 6. I'll just take a small step here with x squared plus x minus 6. What I'm doing from there is factor if I can, quadratic if I can't. I can factor that, x plus 3, x minus 2. So -3 is an answer, +2 is an answer. I have 3 answers for an x cubed problem. For this last one, this x to the 4th problem, we could have up to 4 answers. Once we get down to x squared, we're going to be able to either factor or do quadratic. So on this one, we're going to end up having to have 2 lucky guesses. Our first lucky guess will get us reduced from x to the 4th to x cubed. The next lucky guess can reduce us from x cubed to x squared. Once we get to x squared, we're good. We've been doing x squared problems since Algebra 1 together, factoring, or in this year of Algebra 2, doing the quadratic formula. Tomorrow's lesson will be part of some tips to help you guess better. But my best tips for today are, again, try to see if these all added up made 0, which they don't. But if these all added up made 0, 1 will absolutely work as a guess. It's not a guess, it's a guarantee. Another good tip is, if you see only positive numbers, only try negative numbers there. There's no hope a positive number could work here, because as we add down, things only get bigger. And as we multiply with positives, things would only get bigger. You'd never get back to 0 again. And we're trying to get to 0 is our goal. So with a list like this where it's all positives, only try negatives, negative something. So if there were people here, I would say, hey, yell me a negative number, people, and you'd yell it and I would try it. Personally, I'd start with -1, keep life simple. If that fails, try -2. If that fails, try -3. If that fails, try -4. And eventually, you'll come into something that works. But if I try -1, I would drop the 1, times that, add down, times that, add down, times that, add down, times that, I get 0, hooray, celebrate. I should have written on here an equals 0, but I ran out of room, but there would be an equals 0 for these problems. This was x to the 4th, so this just got us down to the world of x cubed, which we're not ready yet to do by Algebra 1 based skills. What we're going to have to do is reduce this again. Don't go back to the beginning bigger problem and guess again there. You've already made a step. Guess into the step you made, because these numbers, it's a smaller problem than where we started. We're trying to reduce this problem each time. So we got our lucky guess. We're going to try again. These are still all positive numbers, so I would try a negative number. I would probably not try the same number again. Odds are against the same number hitting twice. It could, but it's unlikely you're going to get -1 hitting again. So I might try -2. And I'll go again. Drop the 1, times -2. Add down. Times -2. Add down. Times -2. Hooray, it's 0. So this is answer number 1. This is answer number 2. This reduced us to x cubed. This just reduced us to x squared. We're looking at x squared plus 7x plus 12. We're hoping that can factor. If it can't, we would do the quadratic formula. This would be A, this would be B, this would be C. We would do the quadratic formula. You could go back and find that if you needed it. But this factors. With a plus here, these are both the same as that. Multiply to 12, add to 7, that would be 4 and 3. The x plus 4 gives you a negative 4. The x plus 3 gives you a negative 3. And we have 4 nice answers for an x to the 4th problem. Well, we're good. Let me take a brief look at homework page to just give you a little bit of guidance. And we're on 473, and we're skipping the 3's. So the first 10, they want you to find the quotient and the remainder. So you would be working answers like this by doing synthetic division. Whatever power the problem started with, you'll start one problem lower for one power lower. The remainder is always the corner square, but the first 10 is dividing. 11 through 14 are like this. They're giving you a number to plug in. You put it in the square, you synthetic divide, and your answer is just the remainder box. On 15 to 18, it's asking you if a certain thing is a root. So put it into the box exactly as it is. You're hoping for 0 here to say yes or no, but don't just give me a paper that says yes and no. Show me the synthetic division that you did to lead to that result. 19 through 24, I erased a problem that was here, but again, it's a synthetic division problem. It would ask you if something is a factor, so you switch the signs and put that in the corner square and do synthetic division. 25, 26 are like the one that I had here that gave you like a tip to get your problem started. 25, 26, ultimately we're looking for 3 answers, but they're going to guide you through the first guess to get the first answer. 27 to 34 are like these. Without any kind of tips, they're just saying find all the answers. X to the 4ths would have 4 answers. X to the 3rds should have 3 answers. You just need to make a guess to get yourself started, but eventually you're going to end up with some factoring at the end. There are none in today's that involve the quadratic formula. They're going to take it pretty easy on you in terms of the numbers that work. You're not going to have to guess numbers like 73 or even 11 or even 5, I don't think. The biggest answers on this, every answer on this is somewhere between like -5 and 5. So you don't need to be trying to guess initial numbers bigger than 5s. And there's a lot of 1s and 2s, -1s and -2s that are going to work for your guesses. So don't get too exotic when you start guessing your initial guesses. I'd stick to 1s, 2s, maybe an occasional 3. But if you need any more help, email me, we'll talk on Zoom.
Call. It's not that easy.
Hello, Teddy? Hey, no, this isn't Cap's phone anymore. This is the Math Wizard. What's up? Yeah, Cap isn't here. But I have been thinking about that problem you were having with your time travel machine. I think if you would try a Mobius strip, I think that might be the key to the whole operation that could bail you out. Yeah, I think that would work. All right, yeah, hey, no problem. Glad to help you out anytime, bud. See ya.
Sorry, Mr. Stark, but I'm the real Iron Man.